Hello friends, welcome to the lecture on water requirement of crops. In continuation with the earlier lectures, we will see various factors affecting duty, consumptive use of water, irrigation efficiencies in this particular lecture. So let us start. To start and to see the factors affecting duty, let us understand the term duty first of all. What is meant by duty of water? The term duty means the area of land that can be irrigated with unit volume of irrigation water. Quantitatively, duty is defined as the area of land expressed in hectares that can be irrigated with unit discharge, that is 1 cubic, flowing throughout the base period expressed in days. If the water supplied is just enough to raise the crop within d hectares of the field, then a relationship may be found out amongst all the variables as if volume of water supplied it is equal to B multiplied by 60 into 60 into 24 meter cube, where B is equal to base period of the crop in days. We all of us know what is meant by base period. It is the period from first watering of the crop up to the last watering of the crop. Then second is area of the crop irrigated, which will be equal to d into 10 raised to 4 meter square, where d is the area of land expressed in hectares. Therefore, we can find out the value of duty as volume of water supplied per unit area, which will come out as 8.64 B by D. This formula will directly give you the value of duty. Now let us see the factors affecting duty. Since duty refers to the area of land irrigated, if we supply a unit discharge of water for the entire base period, so there are several factors which will affect the duty of water. So these are the factors enlisted: methods of irrigation, kind of the crop grown, nature of the soil, cultivation methods, irrigation system, time and frequency of tilling, water quantity, water quality, climatic factors, base period, method of assessment, canal section, topography of the land. So in general, all these factors will affect the duty. I will explain one or two in short, like if a kind of crop grown, if a crop grown needs more water, for example rice, it needs plenty of water to grow, and if we supply unit volume of water to the rice, then what will happen? It will consume the water as early as possible for its growth, and therefore the area irrigated will be less as compared to the crops which will require less water for their growth. So in case of rice, the duty will be less, whereas if we cultivate wheat, on the other hand, the wheat will require less quantity of water for its growth as compared to the rice, and the depth of water will be less. Water consumed by the wheat will be less than compared to the rice. Therefore, it will allow more area to be irrigated with the same quantity of water, and thereby the duty in case of wheat will be more. If we talk about the nature of soil, in case of sandy soil, the water will easily percolate through the sandy soil, as the interconnected voids in the soil will be more. Therefore, it will increase the depth of water, not the surface area. Therefore, if the depth of water is more, then ultimately the area under its coverage will be less. So in case of soils which are more permeable like sandy soils, the duty will be less, whereas in case of other types of soils like clay soils, in which voids are less and they will allow a little water to percolate, thereby they will allow minimum depth of water and facilitate more area to be covered under the irrigation. So in that case, the duty of water will be more. So like this, every method, every factor, it is governing the duty in one or the other way. Now, what are the methods of improving the duty? Suitable methods of applying water to the crops should be used to improve the duty. The land should be properly plowed and leveled before sowing the crops. It should be given good tilth. The land should be cultivated frequently. The canals should be lined so that there will be minimum losses. The idle length of canal should be reduced, again to minimize the losses. The alignment of the canal in sandy soil and fissured rock should be avoided to avoid the leakages. The source of supply should be such that it gives good quality of water. If the quality of water is not good, then plenty of water will be required for irrigation. The rotation of the crop must be practiced. Volumetric method of assessment should be used. And lastly, most important, the farmers must be trained to properly use the water. Next term is consumptive use of water, CU. Water requirement of crop is the total quantity of water from the time of crop sown to the time of crop harvested. This water requirement may vary from crop to crop, from soil to soil, and period to period. Water required to meet the demand of evapotranspiration and metabolic activities of the crop together is known as consumptive use of water. I will repeat, the water required to meet the demand of evapotranspiration means losses and metabolic activities of the crop together is known as consumptive use of water. So what are the factors affecting this consumptive use of water? These are evaporation, which is dependent on humidity, mean monthly temperature, monthly precipitation, wind velocity in the locality which affects evapotranspiration, soil type and its topography, cropping pattern, growth stage and type of crop, growing season of the crop, method of applying irrigation, irrigation water depth and daylight hours. All these factors will affect the consumptive use of water. Now, irrigation efficiencies. There are two kinds of irrigation efficiencies. What is efficiency? Let us know. Efficiency is the ratio of the water output to the water input and is usually expressed as percentage. Input minus output is nothing but losses, and hence if losses are more, output is less, and therefore efficiency is also less. Hence efficiency is inversely proportional to the losses. Now the types of irrigation efficiencies. First one is water conveyance efficiency expressed as E suffix small c, and second is water application efficiency expressed as capital E suffix small a. So what is water conveyance efficiency? It is the ratio of water delivered into the fields from the outlet point of the channel to the water delivered into the channel at the starting point. It takes the conveyance or transit losses into account. Water conveyance efficiency EC is equal to water delivered to the farm divided by water delivered into the conveyance system. Then water application efficiency. It is the ratio of the quantity of water stored in the root zone of the crops to the quantity of water delivered into the field. It may also be termed as farm efficiency as it takes into account the water lost in the farm. Therefore, water application efficiency is equal to water stored in the root zone during the irrigation divided by irrigation water delivered to the farm. I hope you have understood these technical terms. I request all of you to go through these standard references. If you are having any doubt, you can ask me on my email address dnpaitankar@sanjeevani.org.in. Thank you for listening. Happy learning.